Okay, this is a tape on 3x3s. 3x3s. 3 equations with 3 unknowns. And we're going to go through the same process as we did on the 2x2s in case you've looked at that tape. We're going to solve for x, y, and z in this system of equations by what is called the elimination method, adding or subtracting. So, what we will do is take a 3x3, 3 equations, 3 unknowns, and reduce it down to where we have 2 of these letters with 2 equations. And that gets us back to what we've previously done before. So, we need to get rid of one of the letters. So what do we want to do? Well, let's do this. Let's get rid of the x's. Here we have equation 1 and equation 2. So if I multiply equation 2 by the coefficient of equation 1, if I multiply this one down here by the 3, and I multiply this equation by the coefficient of here, which would be 1, and then make one of them minus. So as we see on the screen, we're going to multiply the top equation by positive 1. We're going to multiply equation 2 by negative 3. So we multiply equation 2 by negative 3, and we'll get a minus 3x plus 12y minus 3z is equal to a plus 9. And we just copy down equation 1, which is the same thing as multiplying by 1. So we add here, and the x's drop out, and we have the y's, z. So we will now label this equation 4, and I'll talk about that in a minute. All right, now we go back to our original 3 equations and say, all right, I got to get rid of the, I got to get rid of the same letter. I got rid of the letter x up here, so I must get rid of the letter x, picking another pair. So I can take equation 1 and 3, or I can take equation 2 and 3. Well, if I take 1 and 3, I'll have to multiply the top one by 2 and the bottom one by 3. Whereas if I take these two, equation 2 and 3, all I have to do is multiply this by 2. And let's say multiply this one by minus 1. So looking now at what we do in the notes, we're going to take equation 2, multiply it by 2, and so we get 2x minus 8y plus 2z is equal to minus 6. We will multiply equation 3 by minus 1, so it'll change it over to negative 2x plus 3z is equal to minus 8. And now adding here, again the x's drop out. 8 minus 8y plus 5z is equal to a minus 14. We now label this equation 5. So we have equation 5 and equation 4. So we go over to the side, as you see in the notes, and we rewrite equation 4 and equation 5. And now we're back to solving 2 equations with 2 unknowns. Well, how do we do that? Same method. Let's get rid of a letter. So I'm going to get rid of the z. So I'm going to multiply the top by 5 and the bottom one by 4. So multiplying equation 4 by 5, I get 70y minus 20z is equal to 75. Multiplying equation 5 by 4, I get this. Adding now, we come down and z's drop out, and we get 38y is equal to 19. Now how do I solve for y? I divide. These are connected by multiplication, so to move it across, I do the opposite operation. And so I get 38's are gone, I get y is equal to 1/2. All right, now, that's one of the 3 letters. To find the other 2 letters, what we will do is take this value for y and go back and plug it in equation 4 or 5. So let's go back to equation 4 or 5 and plug that value in one of them. So what we'll do then is to take equation, let's say 5. We have a minus 8, y is 1/2, plus 5z is equal to minus 14. This gives us a minus 4 plus 5z is equal to minus 14. This gives us 5z is a minus 10. So we end up getting z to be a minus 2. The way we get that is we divide both sides by 5. So now we have two letters now. We have z is equal to minus 2 and y is equal to 1/2. Now what we do is go back to one of the original equations. Go back and get one of the original equations. So let's take equation number 1. Equation 1 was 3x plus 2y minus z is equal to 6. And we go plug these values in. So that'll give us 3x plus 2 times 1/2 is 1 minus a minus 2. So what we have is 3x plus 3 is equal to 6. Move the 3 across. This will become a 3. Now we divide both sides by 3. And what do we get? X equals 1. So let's rewrite this. So we have x equals 1, y is equal to 1/2, and z is equal to a minus 2. Now at this point, remember now we used equation 1, original equation 1. What you should do is to take these three values and plug in one of the other original equations and see if that checks. So let's see if it does. If we take equation 2 and put just go ahead and write it down. Equation 2 was x minus 4y plus z is equal to minus 3. If we go plug a 1 for x, then this would be 1. A 1/2 here. 4 times a half is 2. Put a 2 there. And z is a minus 2. Replace that with a minus 2. And sure enough, it checks out. So apparently we did this correct. So the solution set to this is the single point 1, 1/2, -2. So if you remember the concept of consistent, no solution, many solution, then we would have the answer to this problem would be one solution, consistent system of equations, and the three planes, the three sheets of paper intersect at one point, which is this one. All right, let's look at example 2 now. And what we're going to do now is look at cases where we don't have a single solution and what happens to us when we use this method. All right, example 2, we have this system of equations, three unknowns. And so let's get rid of a letter. Well, this time I'm going to pick out y to get rid of. It doesn't make any difference which letter you get rid of. We want to get rid of y. So here, hey, I can take equation 1 and 2 and multiply this by 2 and I'll have what I need. So therefore, equation 1 we will multiply by 2. So we get 6x plus 4y minus 2z equals 12. Now don't forget to multiply the constants. Equation 2, we will just copy it down, which again is saying the same thing as multiply by 1. And so when we add, the y's drop out and we get 7x minus c is equal to 9. And we will label that equation 4. All right, now let's take equation. All right, now let's try to get our equation 5. So we will take equation 2 and 3. So we'll take equation 2 and multiply by 2, and we get 2x minus 8y plus 2z equal minus 6. And we'll take equation 3 and multiply by minus 1. So we get a negative 2x plus 8y minus 2z is equal to plus 6. Now when we add, the x's drop out, y's drop out, z's drop out, numbers drop out. So we get 0 is equal to 0. So if everything drops out, all the letters and the numbers, then we're looking at one of these mini solutions. In other words, we don't have equation 5. We don't have another equation. So let's go look over here and see what we do. So we have equation 4. 7x minus z is equal to 9. We don't have an equation 5. That means we can't really take and solve and get a single value number for x and y and z. So what we'll do is come up here and take equation 4 and solve for z, okay, or solve for x. It doesn't make any difference. In fact, I'll do both of them on this tape. So I'm going to solve for z because I don't have any fractions that way. So I'll move the 7x across, and I'll have a minus z is equal to minus 7x plus 9. I will now divide through by minus. And what do I get? Z is equal to 7x minus 9. All right. Now, I'm going to go ahead and let x be equal to t. Just make up a letter to make a difference. I'm going to let whatever this letter is right here be another letter, what we call parameter. So I'm going to put a t there. So looking over here, we're going to take equation 1, or 2 or 3 to make a difference. I'm going to use equation 1, original equation. I'm going to put a t for x. And then over here for z, I'm going to put that 7x minus 9, but in place of the x, I put a t. So then I'm going to solve for y. And so now I have y in terms of t. So what I do then is I say, okay, here is a general solution of the problem. I let x be t. When I did that, I found z to be 7t minus 9. And then from that, I found y to be 2t minus 3 halves. So that's a solution for those many points. Many points. Well, let's look at exactly one of them. So what I do is I make up a value for t. I let t be 1. If I put a 1 here for t, I get x is 1. If I put a 1 here for t, I get 2 minus 1.5, so I get a positive half. If I put a 1 here for t, I get a negative 2. So one of the dots, one of the solution points, is the point 1, 1/2 minus 2. We can pick another point. If I let t be 2, if t is 2, what happens? Well, x is 2. I put a 2 here, I get 4 minus a half, 1.5, excuse me. So that's 2.5, or I could write it as 5 halves. And if I put a 2 here, I get 14 minus 9, so z would be 5. And then you make up another point for t, and so you get many, many solutions. Now let's go back at this point and look at another way that some other people would rather do it, and that is, let's solve x, taking equation 4 again, 7x minus z is equal to 9, and let's solve for x. We would have 7x is equal to z plus 9, so we'd have x is equal to z plus 9 divided by 7. Or we'd have x is equal to 1/7 z plus 9/7. Now in this case, we let z be equal to t or a or whatever letter you want to use. And therefore, if that's true, x then is equal to 1/7 t plus 9/7. And now we have to go solve for y. So let's go back and look at equation 1 and do that. Okay, so here we would have 3 times x, which is 1/7 t plus 9/7, plus 2y minus z, which is t, is equal to 6. So we get 3/7 t plus 27/7 plus 2y minus t is equal to 6. Well, what's a good way of working this one? Several ways. Let's just add the t's together. We have 2y, we have 3/7 of them minus 1, so that's a minus 4/7 t. And this is 27/7, so moving across we have 6 minus 27/7. So now let's do some simplifying. We have 2y, moving this across we have positive 4/7 t, and this would then be what? 15/7. All right. So now dividing by 2, we get 2/7 t minus 15/7. 14ths. So now we have, for a solution, x is this, y is this, and z is that. And then you can make up values for t, and we'll get the same. Well, let's check that. What do we get if t is 1? Remember what we got a while ago. If t is 1, if I put a 1 here, that's 1/7 plus 9/7. So that's 10/7. And put a 1 here, I get 2/7 minus 15. This is 4/14. Minus that, we get a minus 11/14. And we put a 1 here. Well, hey, that doesn't look like the same thing. Well, it doesn't, but it's still one of the same points. Remembering a while ago, we let t be 1, and that made x is a 1. So what we want to do to say, hey, let's see if it still checks the same. What we want this to do is to be a 1. What do we have to let t be equal to for our x to be a 1 like we got a while ago to see if it matches the other values of y and z? So if I want this to be a 1, what I need is this to be 7/7. So if t is a minus 2, what would I get here? I get a minus 2/7 plus 9/7, which is 7/7, which is 1. Now let's see if these other ones work out. Hey, t is a minus 2, z is a minus, that's right, that's what we got a while ago. And if t is a minus 2 here, we get, remember this is 4/14 times a minus 2 is a minus 8/14. Right? And a minus 8/14, I'm going to do something wrong, let's see, a minus 2 would be minus 8/14, minus 8/14 minus 15/14. Let's see, something not checking on that. If t is a minus 2, this is a minus 8/14, and maybe I made a mistake on my 15/14. This would be 42 minus 25, which would be 15/7. Minus 23/14. There's my mistake. This should have been a plus 15/7. Plus 15/7. Now it works. So we got that corrected. This would have been a plus 15/7. Now we have a minus 8/14 plus 15/14, which is 7/14, which is 1/2. And so we get the same value. So let's go back now and look at example 2 back at this point where we have equation 4 and 5. So here's what we need to review. When we're working 3 equations, 3 unknowns, and we come down to where we get everything to drop out, we get a 0 equals 0, then we're going to have many solutions. And what we do there is to come along and get x in terms of, y in terms of, and z in terms of another letter. And this then, as we write that, gives us our solution. Now don't forget this though, if we come down here and get a 0 equals to a number, then this is a no solution. So it follows the same pattern as we had with 2 by 2s. Alright, now let's look at working these by Cramer's rule. Alright, let's look at doing this example 1 again by using Cramer's rule. So Cramer's rule says the denominator will be the coefficient of the x's, coefficient of y's, coefficient of z's. The numerator solving for x, I will replace the x column with the constant 6, minus 3, and 8. If I'm solving for y, and I don't have this in the notes, if I'm solving for y right here, I would replace this column. And so I would write down 3, 1, 2 up here, and then replace this column with the 6 minus 3, 8, and then write down the z column. If I were solving for z, then I would replace the z column with the 6 minus 3, 8. So let's go back to x, rewrite the denominator down, which are the coefficients of the x, y, and z. The numerator, if I'm solving for x, I replace the x column with the constants, what are considered to be the constants, 6 minus 3, 8. Write down the y and z's. And now let's work this. Now noticing in your notes, at the top corner of the page, we have what are called the cofactors, the plus, minus, plus, minus, plus, minus, plus, minus, plus. Start at this corner and go plus, minus, plus. Starting here and coming down, you start plus, minus, plus, and continue that pattern. Those are the cofactors. That's going to be this plus minus sign that I'm going to place out here. And then I place it here, and so on down, as you can see in the notes. Now, this is called the cofactor minor method. Just in case somebody wants you to do it this way, I'm going to show you. Then I'll show you another method here in a minute. What we will do is pick this row. We can pick any row, any column that we wish. We will pick this row and use it. So I'm going to take the 6. I'm going to mark out the column that it's in, the row that it's in, and what's remaining is what's called our minor. I'm going to take the 6, and I'm going to mark out the row and the column that it's in. All right, so let's look back over here. I'm going to mark out the row and the column that it's in, and what's left is what we call the minor. All right, then I'm going to come along and take... Okay. Now I have a minus 4 here, and that's because this was supposed to be a minus 4. All right, and I don't think I had that a while ago, so I'll place that in there, and that's why this is a minus 4. So marking out this row and this column, I write that in. All right, and then I take the next number on row 1. So I'll put the 2 down, and then this minus is because of the cofactor, plus, minus, plus bit. I mark out the row that it's in and the column that it's in, and what's left is the minus 3 and the 8 and the 1 and the minus 3. So that's its minor. Then I come over here and take the 1 here. It's a negative 1. I mark out the row and the column that it's in, and what's left is this value. All right. And doing the denominator, we'll pick, I'm going to show you this. The denominator, I'm going to pick the third row. And the reason I do that is because it has a 0 in it. So that reduces one of my multiplications. So I'm going to take 2. We'll see it's plus, minus, plus. So that's a plus. Mark out the row and column. And that's what I have. Then write the 0. Well, 0 times anything here is 0, so I don't have to write it down. And then I pick the minus 3. Mark out the row and column. And it's what's left is its minor. Now then, I go work this. Let's look now all this expanded. So we have here 6 times. Multiplying down is positive 12. Minus 0 is 12. This is a minus 2. Multiplying down is positive 9. Minus 8. Remember when we multiply up, we change the sign. So multiplying down is a positive 9. Minus 8, that's a plus 1. And here I have a minus 1 times, multiplying down is 0, multiplying up is a minus 32, but I change the sign, so it's a plus 32. And so what do we have on top here? We have 72 minus 2 minus 32. Okay, so that's 70 minus 32, which is 38. All right, let's do the denominator. Denominator would be 2 times, multiplying down is 2, multiplying up is a positive 4, but we change the sign to a minus 4. So multiplying down is 2, minus 4 is a minus 2, 0. Minus 3 times, multiplying down is a minus 12, multiplying up is a minus 2, remember, change the sign. Minus 12 minus 2 is a minus 14. So here we have 3 times 14, which is 42, positive 42, minus 4, which is a positive 38. 38 divided by 38 is 1. So we get x to be 1. Okay, and that's what we got a while ago. All right, I want to come back and show you another method of getting this same work. So let's come back in here and do this for this problem. Another way, and a easier way on 3 by 3, is to come along and replace, just copy down the first column. Let me rewrite this, it looks pretty bad. This is 6 minus 3, 8. Okay, and this is minus 1, 1 minus 3. And this is 2 minus 4, 0. All right, we will replace, or recopy, excuse me, the first two columns. First two columns. And now we're going to work it. Now, remembering, write this down, in a 2 by 2, we multiplied down, and that we wrote down whatever that was, and we multiplied up, and we changed the sign. We're going to use the same process this time. What we'll now do is multiply down where we have 3 numbers. So multiplying down here would be minus 3 times a minus 4 plus 12 times 6 is 72. Multiplying down here, because we have 3 numbers, so that's a plus 16. And multiplying down here, which is 0. And then we multiply up. Multiplying up here, we have a negative 32 times a minus, which is a positive 32. I'm sorry, we change the sign now. Remember, when we multiply up, that's a positive 32, so we have to change it to a negative 32. Multiplying up here is 0, and multiplying up here is a positive 18. Okay, but remember, again, we change it to a minus 18. All right, so what do we have now? On the denominator, let's multiply down, and we get 36. Multiplying down, we get 4. Multiplying down, we get 0. Multiplying up, we get a positive 8, but we change it to a negative 8. Multiplying up, we get 0. Multiplying up, we get a minus 6, but we change it to a plus 6. Well, let's see. What do we get now? Up here at the top, we have 72 minus 32. 72 minus 32 is 40. And we have a plus 16, and a minus 18 is a minus 2. So we again get the same answer we got a while ago, positive 38. And here we have 36 and 4 is 40, minus 8 is 32, plus 6 is 38 again, and we get the same answer. All right, now, I'm not going to show this on the tape, nor do I do it in the notes, but if you were to solve for y, then you would come along and make the denominator 38, and then work that numerator, replacing the y column with the 6 minus 3, 8. Go work out that determinant and get the same answer. Okay, let's look at example 2 now and discuss what happens when we get these special cases, this no solution or mini solution. So looking at example 2, we're going to solve for x. Solving for x again, the denominator are the coefficients of the x's, coefficients of the y's, coefficients of the z's. And then we write down the first 2 columns, and let's just see what this is now. Multiplying down is a minus 24. Multiplying down is a positive 4. Multiplying down is a positive 8. Okay, multiplying up is a positive 8, but we change the sign to a negative 8. Multiplying up is a minus 24, but we change it to a plus 24. Multiplying up is a positive 4, but we change it to a negative 4. All right, Well, what happens here? There's a minus 24 and a plus 24, that's 0. And there's a plus 8 and a minus 8, that's 0. And a 4 and a minus 4, that's 0. So our denominator is 0. Well, we better go work our numerator. All right, so let's go back over here and multiply down. We get, this is minus 8, minus 48. Multiplying down, minus 12. Multiplying down, it's a minus 24. Multiplying up is a negative 24, but we change the sign to a plus 24. Oops, look at there, that's 0. Multiplying up is a minus 48. Change the sign to plus 48. That's 0. And multiplying here is a minus 12, which is plus 12, and that drops out. So we get 0 over 0. Now listen to this very closely. We get 0 over 0 for x. We must then go get y. If we get 0 over 0 for y, and then we must do z, and we get 0 over 0 for z. If we get all of them to be zeros over zeros, then it is a mini solution. And you have to go back and do the work that I have on the other part of solving z equals t and y equals z's and x equals z's and that type of thing. So that's a mini solution. Now, if for some reason in here we got a number 5 over 0 or 1 over 0, a non-zero number over 0 for one of the letters, we get to stop at that point and say no solution. You do not have to check all three, and that's the difference now. You must get 0 over 0 for all three letters for it to be a mini solution. But for a no solution, if you ever run across one time that you have a non-zero number divided by 0, then you get to stop there, and it's a no solution tape. Okay, this concludes the tape then on working 3 by 3s by elimination method and by Cramer's rule.